Hi, it's exam one review, right? Whoa, what just happened? My. Oh, that's good. No, I didn't say exit. Go away. There we go. Hi, everyone. That was scary for a second. It worked out. So yeah, exam one review. It's tomorrow. We have chapters one and two. Chapter one is on functions in general, talking about domain, range, function transformations, right? Shifting and reflecting and all of that. Talking about linear functions and slope, talking about inverse of functions, compositional functions, and those word problems. And then chapter two on polynomials, especially talking about the quadratic in one of the sections, and then rational zeros and factoring and dividing and all of that stuff. And then you have 2.6 on rational functions, where you were introduced to asymptotes, and we try to graph those. So I'm interested in what are your questions regarding the exam. If you did those sample exams in my MATLAB and came up with some questions.
Mm,
Anything at all?
Is it all going to be open-ended?
Yes.
Okay.
That's why you are sending in the work for partial credit and all that kind of stuff if
hmm
anything ends up being wrong. Not that we are expecting anything to be wrong, but just in case.
Okay.
I'm not sure if you said this was going to be on the exam, but the questions that like have the equation x equal negative b plus or minus the square root of b squared, like those type of questions.
Oh yeah,
Can we?
definitely. That is the way to come up with roots for quadratic.
Mm-hmm.
So when we have those larger polynomials, let's say you have f of x equals to, I don't know, 3x to the fourth minus 4x cubed plus 6x squared minus x plus 12. I don't want 12. No, 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 not 12. 4. Okay, 4. 4. Whew. Okay, that was close. And you do the pers, right? The possible rational zeros. You have your factors of 4 and your factors of 3. And then you work the, well, let's just write all of the plus minus 1, plus minus 2, plus minus 4, plus minus 1/3. Oh my, this is gonna be bad, but that's okay. Plus minus 2/3 and plus minus 4/3. Got all of them. So when you get all of that in, you get to check and figure out if any of these are roots. You have to find two by guess and check, and then that will reduce you down to the ax squared plus bx plus c equals 0. So find 2 by guess and check. This is where you do the synthetic division, right? You try plus 1. If it doesn't work, you try minus 1. If it doesn't work, you try plus 2. If it doesn't work, you try minus 2, right? And eventually, hopefully you will come up with 2 of them. And then you will have that polynomial left over on the bottom. So when you get that square polynomial, this is where negative b plus minus b squared minus 4ac over 2a kicks in to come up with the last 2 roots. Because when you find 2 roots by guess and check, that's x1 and x2. This one will spit out x3 and x4 because you need to have a total of 4 roots because your equation was, let's say, the fourth equation. So the amount of roots is always equal to the exponent, the order of the polynomial. So the seventh order will have 7 roots. You are not guaranteed for all 7 roots to be real. Some of those could be complex. Complex roots always travel in pairs, right? Complex conjugate pairs. And they are always found, right, through this equation, because then number under the square root would be negative and it would give you the complex roots and so on, because we can't factor into complex roots easily. I mean, methods exist, but we don't do them in this course. Okay, so you will be using this equation for sure.
For the PRs, whatever. So it's the factors of the constant term over the factors of the leading coefficient.
That's correct, and I'm just going to offer you another way to remember that, which in my opinion would be the more common sense way to remember, which is the way actually I remember, but I don't know. It's common sense to me. See, you can never have this one to be 0 because that would kill the polynomial of that order, right? And because that one can never be 0, it better be in a denominator all the time.
I see.
Right?
Mm-hmm.
So that's the connection that I made, right, when I seen this for the first time, because I said, oh, okay, right, because you can have a 0, right? You don't have to have this +4 at the end, right? And then you just have 0 up there, which tells you factor an x, right? So this 4 could be there, does not have to be there. And that is why we have it here, because that could be a factors of 4, but it also could be 0. It's not going to break mathematics. Where the denominator is not allowed to be 0, but also the front coefficient is not allowed to be 0, because if it's a 0 here, then that kills the leading term, and the polynomial is no longer of the fourth order. It's now of the third order, because fourth order had a 0 on the leading coefficient. Cool. Anything else that we should consider?
I'm just looking through my notes. Give me a second.
That's okay.
Can I get a refresher on domain and range? Finding them?
Well, that's a really wide category to talk about, because there are rules for each function. So polynomials are the easiest for domain, right? Because domain for all polynomials, whether it's linear, quadratic, or whatever, they're all real numbers. But you have to be careful for other functions. So domain is the set of all x values that you are allowed to plug in. So if you think about it critically, right, you will say, oh, okay, so what are the values that I'm not allowed to have? Which brings you to, let's say, rational functions, where you are not allowed to have denominator to be 0. So if you're looking for the domain here, right, again, this is critical thinking, because you can't memorize every case. You would say, so for this function, right, what are the values that I'm not allowed to use? And you will say, oh, okay, x minus 3 equals 0. I'm not allowed to have 0, right? So x equals to 3 has to be kicked out. And I can kick that out by excluding 3 from the infinity of all numbers that I can use. Another one is the square root of, let's say, x plus 6. And you say, the number under the square root must be non-negative, because negative numbers make complex values. So as soon as you realize that, then the common sense would be to say, okay, x plus 6 needs to be bigger or equal than 0, which means x larger or equal than 6, which you can write 6 to infinity as, sorry, that's a negative actually, negative 6 when you move it. So these are all the numbers that I can use to plug in. Now the range is way trickier than this, because the range, you need to see the function and you need to see the lowest value, right, on the y. You can't compute those. I mean, you can in calculus and so on, but you can't compute now. So if you don't have the function, the graph, you don't know what the graph looks like, uh, technically you're doomed, right? So if I have like domain plus range for y equal x squared minus 3, right? Well, domain is easy because you learned that domain is all real numbers, right? But now for the range, like, what is it? And for that, you need your graph. But luckily, right, in 1.6, you know that this shifts graph 3 units down, and you know that x squared is a basic parabola U-shape graph. So you know that your graph, looks like this. I'm just going to do this first, and I'm going to show this because that's a negative 3. So now you look at this and you say, okay, the range is going to be starting at negative 3, because that's the y elevation where all of the y values start, and it goes up to positive infinity, right, in a range. So range are all y values that you can get, right? So this is one y value that you can get. There's another y value you can get. There's a 0 as well. There's this y value, right? But there is no y value here because there is no function for you to reflect into that y value. So domain is the set of all x values that are possible to be used for calculation, and range is the set of all y values that result in those results in those calculations. And as I said, it's different for every function, and you always have to keep your head wrapped around, okay, what is the method for me to get this particular domain or range? And they can combine too. That makes everything more interesting. Like having a square root in denominator, for instance. Well, anything else?
Yeah, can we do example one of the even and odd functions?
Yeah, which one? You have to find the exact example you're interested in.
Yeah, let me find it.
Mm-hmm. While she's looking for examples for even and odd, anyone else has anything ready?
Actually, it's not so much like an example. If we could just practice solving like them to know whether a function is odd or even, because I know for even it's f of negative x should equal f of x, and then for
Yes.
odd.
So
If we
that's why I
could,
said just give me the problem and I'll plow through it. Trust me.
okay. Um. Okay, f of x is equal to x to the third power plus x to the fourth power.
Awesome. All right, so we're going to check even in this case, which is f of negative x needs to be f of x. Okay, well, let's find f of negative x. That's going to be negative x cubed plus negative x to the fourth. And the negative survives for the odd exponent, but it disappears for the even exponent. And now you see that this is not the same as original problem, so we got not even, right? It does not correspond to the original problem we started from. Okay, how about odd? Well, for that we need f of negative x to equal negative f of x. So I already calculated this. I know it's negative x cubed plus x to the fourth. And if I factor out negative, right, to mimic this, if I factor out negative, I get x cubed minus x to the fourth. Well, now this doesn't match original function, right? So this is not the same as negative f of x either, so it's not odd either. Well, it's not even, it's not odd, that means it's neither, which is okay, right? Functions don't have to have the symmetry that even and odd functions give us. So there is the example of calculating both, so this function is neither.
Thank you. And then one more time, did you say you were going to do the PDF as well in addition to the recording?
Yeah, I'll do both.
Thank you.
The PDF will be posted in your in the Canvas under files where the syllabus is.
Thank you.
You're welcome. Any other problems that we should compute?
I don't have a problem. Just a quick question.
Mhm.
Just a refresher. When you take I, comes the like letter I comes from the negative in a square root, correct?
Okay.
No,
So
that's what I'm asking. Like, what the I takes away the negative, right?
yes,
Okay. I just want to make sure.
I gave you an example of negative 16.
Thank you.
So this will be possibly the part of calculating this formula, right? If the formula is to give you complex values, you will have negative under that radical, and it will work out this way. So that's how you get complex numbers there. Anything else?
I know in like section maybe 2.3, we did like the M4 and the M1 things. Can we do a problem and determine which graph it's like? I think that's what we
Yeah,
have to do.
just let's get the problem. We'll go through it.
Okay, I'll give you a problem. Ready?
I was born ready.
-2 parentheses x minus 3 parentheses with the square root. I mean with squared. Just
Okay.
square the okay. And then plus, I think, x plus 1.
That's it.
Yes.
Okay. So if this is our problem, I immediately see that my what do you call it? The leading term over here is negative 2x cubed, right? Because I have this negative 2 here, and I have two x's in this one because of the square, and a single x there. So that's 3 x's on a pile. So this is my leading term. Now I need my leading term because this one says it's odd, and this one says it's less than 0, a less than 0. So together, right, they tell me that my end behavior is this way. So I need that information to get the end behavior. Now over here I have x equals 3, which is m2 root, which is a bounce. And over here I have x equals minus 1, which is the m1 root, which is a straight through pass through, right, for the root that it's m1. And now I can graph because I know everything I need. I have, actually I'm going to move this y-axis right here. So I have 1, 2, 3. I have -1. So these are the two roots. And I need to have my setup, right, to the left and to the right the way this is. So now this is the m1 root and this is the m2 root. Okay, so to connect this, I have to shoot straight through m1 root. You shoot straight through it. That was the rule. And then m2 is the bounce. which is good for us because look, I exactly have to bounce off of it to go into this. Because if I imagine if it wasn't a bounce and I just had to cross through it, then I would have to cross again to connect with this, but I don't have an extra x-intercept to do that, right? So, as I said thousands of times, right, everything in mathematics has to always click perfectly. So now, when you do this one and you bounce off of it, see, it immediately connects here, and it's perfect fit for what we had up there. So anytime you see a square, that immediately means it's M2. When you see a cube, it's M3, and so on. Now, this was the exponent of 1, which means M1. And then you go and you learn what we did in class regarding M1 is a pass-through, right? It shoots through. M2 is the bounce. M3 is the cubic pass-through, meaning like that, and going down. So no matter what kind of root you have, it mimics the original polynomial function on that pass-through. Anything else?
I did have one other thing. I'm trying to look for it. It was the one with the division. It was like a bunch of division. It wasn't the synthetic one. I think it was factor theorem.
That's technically all the same, yeah.
Oh, division of polynomials and remainder factor theorems. Okay, I can give you the example.
Sure.
Okay, so it's x plus 2, and then the division thing, and then the polynomial is 4x to the cubed minus 6x. Oh no, like the
Oh, it's actually I just got it. Ha. Like this.
yeah, like that. It's 4x cubed minus 6x squared plus 5x plus 10.
Okay. And they're asking for remainder, right?
Yeah.
So the way this is written here, the only thing it spells is pain, right? Because you would have to go through all of these horrifying calculations to come up with the answer. There are two faster methods to come up with the remainder than to do the long division. Now, some people love pain, obviously they're going to go through long division. But others would say, oh, this is x plus 2 equals 0, x equals negative 2, which is a root. So now, when I know that, I have two options. Option number 1 is to do synthetic division using negative 2, which is 4, negative 6, 5, and 10, which synthetic division takes very short time, right? That's a negative 8, negative 14, that's positive 28, 33, negative 66, so negative 56, you're done, right? So that was the long division. And some people who like calculations more than this, right, which you can also use when you do the PRS stuff, right, the guess and check, you can say, oh, what's the f of negative 2? Right, so you have 4 and then negative 2 cubed minus 6 negative 2 squared plus 5 times negative 2 plus 10. And this also has to come out to be negative 56 because that was the theorem that we learned. Now you can immediately see that these two cancel. That's a negative 10 and positive 10. So you have 4 times negative 8 minus 24, right? And that, without me going through all of this, blah, blah, it's going to be negative 56, right? So you have three different ways to solve the problem where obviously long division is going to be the most painful one.
So you can always do the just plugging in the root into the equation?
Yes, your entire PERS problem, you don't have to use synthetic division. You can plug in 1 into the function and see if you get 0. If you get 0, it's a root. If you don't get 0, right, if it has a remainder, it's not a root. You go with the next number. So yes, you don't have to do synthetic division at all. It's just that for me, synthetic division is faster because in synthetic division I don't have, like, eventually, right, this polynomial might look like 4 times 2/3 cubed. Yeah, good luck. It's much easier in synthetic division because you have just 1, 2, 3 multiplications and you're done. You don't have to raise anything to the third power and so on. So in some sense, synthetic division should be the fastest, but then this calculation actually could be the faster one. Like if you're using 1, -1, 2, -2, it could be faster. But as I said, if you have 2/3 and you have to cube that and then mess with 4 times 4 and everything else, yeah, it doesn't sound too good, right?
Yeah.
So literally, pick your poison. I don't want to force this one way or another. It is going to be completely up to you guys. You can do entire PERS with long division. Yeah, I know it's going to take an hour, right? But you can do literally every calculation with a long division of polynomials. Or you can do it with synthetic, or you can do it with this. Your job is to get that 0 remainder, because that's the one that guarantees that this puppy here was the root. Now, which way you're going to get that remainder equals 0, right? All 3 methods are available to you. And some of you are faster with synthetic, some of you are faster with, All right? What else do you have?
Maybe we could do a problem where like you have to determine if it's a polynomial or not, or a rational function, something like that.
Which one? Remember, you guys need to give me exact problem. I'm
Okay,
not supposed to come up with problems today. I'm supposed to come up with problems tomorrow. Today you make problems, I give solutions. Tomorrow we switch the role.
okay, ready?
Yes.
X to the 1/2 plus 7x minus 1.
Not a polynomial.
Okay, because of the 1/2?
Good.
Okay. Because it's going to be like a negative
No, it's a
power?
square root of x.
Okay.
And that's not a polynomial. Polynomials are defined as an x to the n. N is the integer. It's always a whole number. So you can't have fractions and decimals in the exponent.
Okay, what about this one? So x squared plus 8, and then divide the whole thing, and then x to the 5th power.
Not a polynomial, because I'm going to get x to the -3 plus 8x to the -5. These n has to be the positive integer. N is the set of counting numbers, 1, 2, 3, 4, and so on, when you are talking about polynomials. So you are not allowed to have negatives, fractions, or decimals, none of that stuff. The only things that you're allowed to have, if it's going to be a polynomial, for every term is going to be just a whole integers, which we call counting numbers, right?
Okay, how can you tell if something is a polynomial from its graph?
Well, that could be tricky, but what I technically I don't want to say I can. I don't think so, because there are a lot of graphs out there. I can distinguish very well between polynomial graphs and exponential and logarithmic and trigonometric, obviously, but there are certain graphs that you can make them look like they're something, but they're actually not. And the correct answer to that question is no, you can't. You can't. When you take a look at the between the two power poles, right, like this, of those, and then you have these wires stretched like this, and they sag, right? When you take a look at that sag, someone would say, "Oh yeah, that's x squared." No, no, no. It's cosine hyperbolic x, which is a function we learn all the way in calculus 2. So it's it's not going to work. So you can't really tell very well. There are indicators of it, right? You can't have any cusps, you can't have any spikes like this or like absolute value. You can't have they have to have infinite domains, so they can't stop. They can't have any asymptotes. Like there are a lot of features that are uh, distinguishing features of the polynomial function, but it's never the whole story. And I just gave you the example of something that might look like, oh, this is a very wide x squared function, but it turns out that no, it's not. It's a cosine hyperbolic function. It's a hyperbolic function that you learn for the first time in calculus 2 class. So yeah, the answer to that is no.
Okay.
Anything else?
Oh, what about the minimum and maximum of a vertex? Do we have to
Okay,
know?
so vertex of the polynomial
Yes.
will be h comma k, which is the
Right.
min max, right?
Okay.
And that one had the formula negative b over 2a and f of negative b over 2a, right, as a point. And then if it opens downward with the a negative, then you have a max. And if a is positive, it opens up, which means it will have a minimum. So that's the theory. Now, do you have a problem that you want?
Yes.
What does it
Okay.
say?
3x squared minus 4x plus 1 or plus
My,
11. So plus
plus
1.
11. So minus 4x plus 11.
Yes.
Okay. Well,
Is that a good problem or no?
of course, everything is a good problem. I hope you love fractions. Um, so h is negative b, which in this case would be minus minus 4, right? Divided by 2 times a, and this becomes now positive 4 over 6, sorry, which is 2/3. So the x coordinate, right, which is h, is 2/3. Now to find the y coordinate, you have to plug in 2/3 into your function. So you have 3 times 2/3 squared minus 4 times 2/3 plus 11, and that is going to give you your y coordinate. Now this is going to be 4 over 3, because one of the 3's cancels, minus 8 over 3, and I'll put 11 over, 33 over 3, because 11, right, to find common denominator. So y is 29 over 3 altogether, because 4 minus 8 is negative 4, and you take it away from 33. So your a is 3 larger than 0, which means it opens up, which means it has a minimum. So your minimum is at 2/3 and 29 over 3. That's your H and K values that you compute by the, the formulas that are given to us in a theory, and then you use A to figure out whether it opens up or down, so that you know whether you have a min or a max. But you're guaranteed to have one or the other. That only depends on A, whether it opens up or down.
Okay.
Cool, huh?
Yeah. Nice and complicated, like I like it. Hmm. Oh, maybe we could do a problem where we have to like find the vertical asymptote and the slant asymptote. I have a problem.
So just let me know the problem.
Okay. I hope this is a good problem. Okay, so x squared minus 4x minus 3. Oh, sorry, I'm going too fast.
That's good.
Over x plus 1 parentheses in parentheses.
Like this, right? These parentheses, if there are parentheses here, they're
Yeah.
not important unless there is a square or something.
Yeah, parentheses there with the square.
Oh, there is a square. Aha.
Yes.
Because they would never just put parentheses there without a square or something. Great. Well, looking at this problem, I immediately see there is a vertical asymptote, there is a horizontal asymptote. There are no slants because you do have horizontal. And yeah, we can let's see what are the things we can find. So the top factors into top doesn't actually factor. There's a -3. You can't. Yeah, it doesn't factor actually. There you go. All right. So vertical asymptote is when you set denominator equal to 0. Since nothing cancels, you get x equals -1. Horizontal asymptote, in this case, you have x squared divided by x squared, because those are your leading terms. And if you FOIL this, you will get x squared as the first term. And since they both have the coefficient of 1, it's 1 over 1. So y equal 1 for the horizontal asymptote. No slant asymptote, because we have horizontal asymptote. They are mutually exclusive. You have one and you cannot have another. Right? So it's one or the other. You cannot have both. And that's technically that's it. Now we could go and try and find x and y intercepts and other things if you're interested in those, and try and graph this, see what it looks like. But if you are asking only about asymptotes, we are done.
Yep, I'm only asking about asymptotes, I think.
Okay. Anything else?
Not for me.
Yeah, as of right now, I don't have anything.
So please make sure you take the pictures of your work. You remember that there is a 5-minute deadline to send it after you finish the exam, which is more than enough time to take a couple of pictures or make a few scans. You can also embed them in, if you know how, you can embed them directly into your exams in Canvas. That's only if you have extra time. If not, then just shoot an email. Please don't send a separate email for each photo. Just sometimes I end up with like 200 emails. To find each one is, try to keep everything if possible in a single email. And yeah, that's technically it, unless you find another problem.
Mm-mm.
That's it.
I think so.
All right then. Well, good luck on the exam, and I will see you all next Tuesday.
Okay, cool.
All right,
Thank
guys.